Hey everybody, this is Mr. Bells. This is a section on, we're going to call, it's a mixed bag of stuff. Partial fractions, some story problem things, and how to use systems to maybe find regression equations for stuff. So I'm going to start off with this one right up here, and if you want to, you can go ahead and copy it down. So what the heck is a partial fraction? Technically a partial fraction decomposition. Well, there's stuff going on in calculus that requires you to do some manipulations. And you can't do a manipulation with a problem that looks like this. So what you have to do is you have to break that problem down into something smaller, and then you can do that manipulation with it. So kind of like, I don't know, cleaning up your dirty clothes before you do the laundry. You don't want to throw everything in there at once. So we have to do some stuff to it. So we're going to try and take this one fraction, which has a quadratic down here in the bottom, and we're going to try and make it to be the sum of two other fractions that only have linear terms down here at the bottom. And if we can do that, then this process called integration in calculus can be accomplished. So that's kind of our goal. So here's the first thing that we're going to do, is we're going to see if the bottom is factorable. And if the bottom isn't factorable, that's a totally separate process that we have to do, which is a little bit more detailed than what we're going to do during this stay-at-home period that we got going on. But if this is a regular class again now, then I'll show you some other stuff during class. Okay, so this thing factors x plus 6 over x squared minus 7x plus 12 into x plus 6 over x minus 3x minus 4, just like that. And then we're thinking that there's some number a and some number b that I could put in the top here and the top here, that I could do over one of the factors and put the b over the other factor, and this would be true, that this fraction plus this fraction would equal this expression. Now, I hope you guys know that when we have fractions with different denominators, we can do that crisscross smiley face stuff that we've done a lot, especially when we're going through that trig stuff. So how does that work out? So I'm going to go ahead and do that right now. And you're going to see that this, if I do Chris right here, down there, you'll see that I'll get ax minus 4a. And then if I do cross, I'm going to get plus bx minus 3b. And then if I do smiley face, you'll see that it's x minus 3 times x minus 4. And I'm going to leave it just like that for right now. And what I want you to do is I want you to look at this term, which we know is what this equals, right? And what this is right here. And if you'll see, the denominators are still the same, right? So if this expression is equal to this expression, the denominators are the same, then that must mean that the numerators are the same. So I should be able to write the linear parts up here, the ax plus bx right here. So ax plus bx technically must equal whatever the x term is over here. So that's 1x. And then the nonlinear terms, the stuff that doesn't have x's with it, negative 4a, this is minus 3b, must equal the nonlinear term right here, and that's 6. And it's like, whoa, wait, that almost looks like a 2 by 3 system of equations, right? So these all have x's in them, and we technically can cancel out those x's. So I'm just going to rewrite it again. So a plus b equals 1, and negative 4a minus 3b does equal 6. Okay? So that's a 2 by 2 system, and you could take that and throw that into your calculator and do an RREF. That's probably the quickest. But honestly, these numbers are pretty small. If I was doing a partial fraction decomposition, we do one of these once in class, again, when we're in class. that takes up all three boards, and you end up with a 7x7 system. It's pretty crazy, or a 7x8 when you throw in the answers to it. But I'm just going to do this one right here by hand because we can do that, right? So I'm going to multiply the entire top line by 4. So that's going to give me 4a plus 4b equals 4, just like that, right? And negative 4a and 4a, poof, that goes. Negative 3b and 4b is a b, and 6 and 4 is 10, so b is 10. Using back substitution, if I put a 10 in right there, then you know that a must equal negative 9, which means my final answer, and again, my final answer is this expression written as a sum of two fractions with linear bottoms. So the a is negative 9, and that goes over the x minus 3. So negative 9 over x minus 3 plus the b, 10 over x minus 4. Okay, so this is what we call a partial fraction decomposition. The ability to change something that cannot be integrated in calculus, this expression, into something that can be done. And again, I'm not going into the details of that. I'm just trying to show you the process right now. And you can practice that all you want. Now, I want to make sure that you understand that this actually does work, so watch. So negative 9 over x minus 3 plus 10 over x minus 4. And again, you don't have to do this. I just want you to make sure the math works out. So I'm going to do crisscross smiley face here. So negative 9x, right? Negative 9x. Negative 9 times negative 4 is positive 36. And then go this way. That's 10x plus 10x, right? And then minus 30. And that's over x minus 3 times x minus 4, which is x squared minus 7x plus 12. And I'm going to simplify that. So I got my linear terms here. So negative 9x and 10x is x, and 36. And negative 30 is 6. So x plus 6 over x squared minus 7x plus 12. And look at that. That, what we started with, are the same things, which means we know that these two things are equivalent. Okay, so that's a partial fraction decomposition, and you can practice some of those ones on the homework, or watch some of the other solving things. I'm pretty sure I've got that on Educreation's videos too, so if you want that. And again, there's bigger rules, crazier stuff. We usually take almost 3 days with this set of materials when we do it, but we're trying to minimize it for what we do here, cut it down. The other thing I'm going to show you is this one. So if I need to do a partial fraction decomposition for this thing right here, the first thing that I have to know now is, look, my numerator and my denominator are both degree 2s. And if the numerator is bigger than the denominators in terms of degrees, or it's equal, then I have to do division first. And you're like, wait, what? Yep. So we're going to do some long division right now. So I'm going to go ahead and do that here. I'm going to do it right below in this spot, and then do my other stuff over here. So that's x squared minus 1 into 4x squared plus 3x minus 2. There's my long division symbol. So how many times is x squared going to 4x squared? It's 4. And I put that over my constant term, right? We've done these in class already. And then I do the multiplication, so that's 4x squared, and then 4 times negative 1 is negative 4. And then what do I do with these terms? I subtract them. So I'm going to make that a minus, I'm going to make that a plus, so I'm basically changing the sign. So 4x squared minus 4x squared goes poof, and I get 3x, right? And then negative 2 and plus 4 is plus 2. So technically what I have right now is I have it going in 4 full times plus 3x plus 2 over x squared minus 1. So I can do integration with 4, that's not a problem. I can now do well, I can't. I have to split this thing up because again, that's a quadratic. But look, that's factorable, and so I'm going to split this up into this. So I'm going to rewrite this as I know there's the 4, and I'm going to write it there, and I'm going to just come back to it later. So I'm going to try and rewrite this 3x plus 2 over x squared minus 1 into two partial fractions. So that's a over x minus 1 plus b over x plus 1. That's just that factored, and we don't know what the a and the b is yet. Okay, so here we go. Just like what we did up here above on these problems, I'm going to do crisscross smiley face and get these two terms. So I get ax plus a plus bx minus b, and that's supposed to equal 3x plus 2. So the numerator of this equals the numerator of this, and you know x minus 1 times x plus 1 does equal x squared minus 1, so I don't need to write it down. They have the same denominators. So now I'm going to line up the linears into a thing. So a plus b equals 3, and then the constants. Then a minus b equals 2. And again, you can throw this into your RREF, but literally it's so easy. I'm going to do elimination method because like the b's are already opposite, so I really get 2a equals 5. So a equals 5 halves, and b equals, if a is 5 halves, then I either have to make 3 or 6 halves, so b equals 1 half. Okay? So then you're like, man, what is my final answer? And I know it looks like I didn't give myself enough space on this paper the way I should have. So final answer, 4, right? That's my 4. That was a constant. Plus, a is 5 halves. So I'm going to put the 5 upstairs and the 2 downstairs. And put what its denominator was. That's x minus 1. Plus the b, which was 1 half. And then its denominator x plus 1. Okay, so that is my final answer. And literally, if we did crisscross smiley face with this section right here, and then got that new problem and then did it with the 4 right here, you would end up with this big thing in the very beginning. I'm not going to take the time to do that because I don't want this video to go super long. But that's what it looks like. Okay? So, one more time. If the denominator is bigger than the numerator, factor it, set up your different fractions, use crisscross smiley face to set up your system, solve your system, and then plug back in to get your partial fraction decomposition. 2. If your numerator is the same degree or higher, you must use long division first to make it smaller, and then whatever is left over, your remainder, then you can go ahead and do what you did in process number 1. Okay? So let's go to 3 now. So this is kind of an interesting thing, and I'm hoping that this follows for you guys. Is this? So I have 3 random points here: -4, 71, -2, 27, and 3, 22. And if you were to do a quick little sketchy plotty thing, that you would see that you get a point way up here and a point right up there and another point up there. And these, I believe it's obvious to tell that they are not collinear. And if they're non-collinear, that means that there definitely has to be a parabola that goes through them. Correct? Everybody agree with that? So we're going to try and find that equation, find that quadratic equation that matches this. So ax squared plus bx plus c equals some y. We just don't know what that is, but we do know that we have 3 points. And you know that 2 points, right, determine a line. So 3 points should determine a parabola as long as those 3 points are non-collinear. Okay, so how do we go ahead and do this? Well, let's plug it in and see what we have. So if x is -4, right, then -4 squared, that would be a 16a. And then x is -4, that would be a -4b. And then you got plus 1c equals some y, and I don't know what it is. So that used that point. So now I'm going to plug the next point in. -2 squared is 4, so I get a 4a minus 2b plus 1c equals y. That's that point. And I got another one, 3 and 22, so 3 squared is 9a plus 3b plus 1c equals y. Now I have 3 equations, 1, 2, 3, and 3 unknown variables. I don't know what the a is, what the b is, what the c is. But if I have 3 equations and 3 variables, I know that I have a system. So I'm going to change this and write a coefficient matrix, or what we call the augmented matrix. So I get 16, -4, 1, 1, right? And except these y's are these terms. Look at that. So instead of putting a y, a y, and a y, I can literally put a 71 here, and I can put a 27 here. So 4, -2, 1, 27. And I can put the 22 in the last one. 9, 3, 1, and 22. And I have a 3x4 matrix. So what are we going to do? You know it. Got it. Grab it. Pop it out. There's your calculator. Let's get this sucker in here and see. So second matrix, over to edit, enter, and this is going to be a 3x4. So I got 16, enter, -4, enter, 1, enter, 71, enter, 4, enter, -2, enter, 1, enter, 27, enter, and 9, 3, 1, and 22, like that. So make sure all those match up for you. And then second home screen, second matrix. We're going to RREF it because, again, if we did it by hand, which 100% we could. I've showed you how to do that in the last video. It just takes too long. So we're going to do this one with some tech. And go to my math, RREF, enter, and second matrix. I'm going to do it for matrix A. So I'm going to have that, right? RREFA. Perfect. And look at that. It gives me my identity matrix. Let me zoom in on this for you. Identity matrix, and shows me that the A is 3, the B is -4, and the C is 7. So 3x squared minus 4x plus 7. So that's my hope. Watch. Now we're going to do a bunch of stuff here. So I'm going to go to y equals, and I'm going to put in 3x squared minus 4x plus 7, just like that. Sorry, it doesn't have perfect zoom on it, but that's there. I'm going to go to my stat, and I'm going to go to edit, and I'm actually going to put in those 3 points. I'm going to do it this way, so I'm going to kind of show you the connection between everything. So -4 and -2 and 3, and then here we go. We got 71 and 27 and 22. And I'm all set there. So I'm going to go here on my window, and I'm going to try and get my x's big enough to fit these ones. So my x min, I'm going to put it -6. My x max, I'm going to put it 6. And my y's, I'm going to go from 0 to 90. Cool. And then I'm going to turn my stat plot on. And I'm going to do a scatter plot so that those plots can come up, L1 and L2. Feel like you're getting pretty good at this. So if you need to pause for a second to try that, go ahead. And then I'm going to hit graph. And look, isn't that crazy? That is the exact equation that goes perfectly through those 3 points that we just solved using systems of equations. Now, last thing on this stat, calc, I'm going to do a quadratic regression for the data that we just put in there, L1, L2, frequency list. I do not want L2 as my frequency list. I'm just going to clear that. I think that'll be okay. And look at 3, -4, and 7. So when it's doing a regression analysis, it's really solving it using systems, or it could be. Okay, so hopefully that was really cool, and you just went like, whoa. Lots of different mathematical applications going into one thing. So I'm going to finalize this stuff with this last problem down here, and I'm going to give you some time to be able to copy it down. So this is a story problem, and I'm going to clear that up. Sorry, it might look a little messy here. So here's my story problem. So I got Savannah invested some money. Savannah invested $30,500 in 3 different investments, A, B, and C. Investment A earned 10%, B earned 8% right here, and C earned 9.5%. And a total interest of $2,742.50 was earned. The amount invested in B is $1,500 less than what was invested in C. How much was invested in each? And you're like, what? So that's a lot of different things there. So what we're going to do is we're going to see if we can solve this using a system. Surprise, surprise, that's what this unit's about. So I believe that this is true, that investment A, let me show this right up here. Investment A plus investment B plus investment C, the total of those 3 investments was $30,500. That's a true equation. That's a total, and it's a total of those 3 things. I also know that 10% of A, 0.1 of A, plus 0.08 of B, plus 0.095 of C ended up being $2,742.50. That the interest that we earned on whatever these investments were ended up being that. So I've gotten 2 totals and 3 relationships between those totals. But you can see I have 1, 2, 3 variables. I got 2 equations. At this point right now, there's nothing I can do, right? I have to have a third equation. So I have to go back and look at this, and it says right here, the amount invested in B is $1,500 less than C. So if I write that over here, that B equals, right? $1,500 less than C, $1,500 less than C, I have a third equation. But what I have to do is I have to line up that equation with these equations. So I know, here's my equal sign, right? So my B is already on the left side, so I can just put that there, B. And you know that that's 1B, just like that's 1A, 1B, and 1C. My C is on the right side of the equation over here, so I've got to move that this way. So that's going to be a minus C, which again is a minus 1C. And then over here, the 1,500, or the negative 1,500 is on the right side. Let's leave that there. So I got negative 1,500. So there's my stuff, right? So let's go ahead and see if we can put that into the calculator. So I'll go on second matrix. Would you guys agree this is best to just use an RREF on your calculator? So let's go ahead and plug this in. So top line, 1, enter, 1, enter, 1, enter, 30,500. I got that. And then 0.1, enter 0.08, enter 0.095, enter 2742.5, enter. And then A's. Do you see the A's? No A's, so we got to put it at 0. 1B, -1C, and -1500 for my constant. Enter. So then I go to my home screen, and second matrix, over to the middle column, up to RREF, second matrix, and I want to choose A. So my RREF A, for what we just did, I hit enter, and it looks pretty. That's a good sign. So it looks like my investments were 5,000. Excuse me, 12,000 and 13,500. So in A, I invested $5,000. In B, actually I didn't. Savannah did. Good job, Savannah. B, 12,000. In C, $13,500. Those were the 3 investments that she made, and if you double check on all these things, take a look, right? A plus B plus C, these 3 things should add up to $30,500. Check, they do. That if I did 10% of A, 8% of B, and 9.5% of C, it should equal $2,742.50, and it does. And that if I take C away from B, 12,000 from 13,500, it does equal 1,500. Okay, that's right there. Right. So 13,500 minus 1,500 equals that. Cool. Nice job. Check mark, smiley face. Hope this section works out really well for you, and you guys do a great job. And we will talk to you later. Bye.